Good morning, everyone. Today, I am going to present a topic on research methodology for engineers. This course is guided by me, T. Harina Reina, who is an advisor at Osmania University, OTBI. In this presentation, we will understand different concepts related to research problem, research techniques, data, analysis, and various methods used in engineering research. This course is divided into 5 important modules. The first module is Research Problem Formulation, which explains how to identify and define a research problem. The second module is Hypothesis Formulation, where assumptions and predictions are developed. The third module focuses on statistical techniques. The fourth module explains statistical analysis of data. Finally, the fifth module discusses how to prepare a proper research report. Overall, these modules help students learn the complete process of research step by step. In this module, we study different aspects of research problem formulation. It includes an overview of research problems, sources from which research problems arise, and methods to deal with research problems effectively. The module also explains the criteria of a good research problem and common errors made while selecting research problems. Finally, it discusses different types of research problems and the importance of logical arguments in research. This slide explains some common mistakes made while selecting a research problem. A research problem should be significant and original. If the topic is duplicated or lacks innovation, it loses research value. The problem should also be feasible, meaning solutions should be practically possible. Research studies may fail if there is poor administrative support or if the supervisor is not interested in the topic. The availability of proper methods and techniques is also very important. Finally, the research problem should match the researcher's competency and should always follow ethical principles. This slide continues the discussion on research problem selection errors. A research problem should be solvable and relevant to current needs. Old and outdated topics may not contribute much to society or technology. The topic should also be interesting both to the researcher and to peers. Ambiguous problems create confusion and affect research quality. The derived solution must be verifiable and scientifically valid. Irrelevant or irregular topics reduce the effectiveness of the research work. This slide explains common mistakes in questionnaire studies. Researchers sometimes use questionnaires for problems that are better solved using other research methods. Another major mistake is not designing or pretesting the questionnaire properly. Asking too many questions may waste the respondent's time and reduce response quality. Details such as grammar, format, and printing style also influence the respondent's first impression. Finally, researchers should check non-responding samples to avoid bias in the collected data. This slide discusses errors in interview-based studies. Researchers should carefully plan interviews and prepare interview guides in advance. Practice interviews are important to improve communication and interviewing skills. Bias during interviews should be avoided by maintaining proper safeguards. Researchers must also ensure the reliability of the information collected. Simple and understandable language should be used so respondents can answer correctly. Questions should only ask for information that respondents are reasonably expected to know. This slide explains common problems in experimental studies. Researchers should treat both experimental and control groups equally to avoid biased results. Using too few samples may produce inaccurate findings and large sampling errors. Sometimes subgroup analysis is necessary to obtain deeper knowledge. Another issue is matching subjects using irrelevant criteria. If too many matching conditions are applied, researchers may lose many suitable participants. Therefore, careful experimental design is very important for accurate results. This slide focuses on content analysis studies. One common mistake is selecting easily available content, which may lead to biased sampling. Researchers should ensure that the selected samples are directly related to research objectives. The reliability of content analysis procedures must also be checked carefully. In addition, classification categories should be clear, specific, and comprehensive for accurate analysis. This slide discusses observational studies. Using untrained observers may result in unreliable data collection. Observation procedures should also be practical and should not demand excessive time from technicians. Researchers must protect the interests and safety of observers during the study. Another challenge occurs when the behavior being studied happens very rarely, making reliable observation difficult. Therefore, proper planning and trained observers are essential for successful observational studies. This slide explains correlation studies and common mistakes associated with them. Researchers should not assume that correlation automatically means cause and effect relationship. Samples with too many varying factors may produce unclear comparisons. Research should focus on meaningful data instead of simply using conveniently available data. Variables selected for correlation must be supported by previous studies and proper theory. In some cases, advanced techniques such as partial or multiple correlation are required for better understanding. Reliable measurement methods are also necessary when studying complex behavior patterns. This slide introduces the different types of research problems. Research problems can be classified in several ways based on their objectives, methods, analysis techniques, and applications. The following slides explain these different categories in detail. This slide lists different classifications of research problems. Research can be descriptive or analytical based on exploration. It can also be fundamental or applied based on the nature of the issue. Research may be quantitative or qualitative depending on the type of analysis. Similarly, it may be conceptual or empirical and field-based or simulation-based. Each type serves different purposes in engineering and scientific studies. This slide compares descriptive and analytical research. Descriptive research explains the current state of affairs using surveys and fact-finding methods. In this type of research, researchers do not control variables directly. An example is studying the frequency of vehicle arrivals in a workshop. Analytical research, on the other hand, focuses on analyzing collected data critically to draw conclusions and interpretations. This slide explains the difference between fundamental and applied research. Fundamental research is based on strong theoretical concepts and pure mathematics. Its goal is to develop knowledge that can be used in broad applications such as FFT or DFT techniques. Applied research is more action-oriented and focuses on solving real-world problems faced by society or industries. For example, finding solutions for diseases like malaria is an example of applied research. This slide compares quantitative and qualitative research. Quantitative research deals with measurements such as size, weight, amount, and volume. It mainly focuses on numerical data and statistical analysis. Qualitative research, on the other hand, studies feelings, opinions, experiences, and qualities such as happiness or satisfaction. Both methods are important depending on the objectives of the research. This slide explains conceptual and empirical research. Conceptual research is based on abstract ideas, visions, and theoretical concepts. It mainly focuses on proposed actions and new ways of thinking. Empirical research is based on practical experience, observation, and experimentation. It is commonly used in engineering studies because it relies on experimental design and real-world evidence. This slide compares field studies and simulation studies. Field studies are based on real field data, physical measurements, and practical experiments. They provide realistic information from actual environments. Simulation studies use computer modeling techniques to study systems virtually. Simulation methods are generally less expensive and help researchers test different conditions efficiently. This slide summarizes all the key points in today's discussion. We discussed errors in selecting research problems and identified 15 important error parameters. We also studied different classifications of research problems such as descriptive and analytical, fundamental and applied, quantitative and qualitative, conceptual and empirical, and field versus simulation studies. These concepts are very important for conducting systematic and effective research in engineering. Thank you everyone for your attention. I hope this presentation helped you understand the basics of research methodology and different types of research problem.